Let's go ahead and start looking at aneuploidy versus polyploidy. So, first up, aneuploidy is whenever you have an abnormal number of chromosomes at a specific location. It could technically be more than one, but in our class, we're pretty much just going to talk about like at the chromosome 3 location, at the chromosome 21 location, or stuff like that. And all of the conditions for aneuploidy are going to end in the word somi or somic, S-O-M-I-C. So instead of the Y having IC. And in polyploidy, this is an abnormal number of chromosomes at every single location, or another way that you can think about it, an abnormal number of sets of chromosomes. And the conditions all end in ploid. So it's really important to remember what the conditions end in, because you have trisomy and triploid, they all start with TRI, and the only way to know what the difference is based on that ending. So you have to remember somi is aneuploidy and ploid is polyploidy. So now let's look into each of these a little bit more specifically, starting with aneuploidy. So, like we said, aneuploidy is an abnormal number of chromosomes and they end in somi. The 4 types that you need to know are nullosomy, monosomy, trisomy, and tetrasomy. So we are going to derive these words and what they mean based on kind of breaking down the root of the word. And hopefully this will help you not only have to memorize it, but that you can, if you forget on an exam what nullosomy means, you can go back and say like, okay, but I know it means this and this, and kind of figure out that it means -2. So for all of these, I want you guys to remember that we have 2 chromosomes at every single location, one from mom and one from dad. And these are all going to be variations of that. In nullosomy, the word null means 0. So that means instead of our 2 chromosomes at a location, we have 0. How many chromosomes did we lose? Well, we lost 2 chromosomes. Going from 2 to 0 is -2. And that's why nullosomy is -2 chromosomes. So in a human who usually has 46 chromosomes, this would be 44 chromosomes. In monosomy, remember we start with our 2, and now mono means 1, that means we only have 1. So we're supposed to have 2, but we only have 1. How many did we lose? We lost 1. So this means in monosomic individuals, they have 1 chromosome less than usual. And in humans, we usually have 46. This would mean having 45 chromosomes. In trisomy, remember we always start with our 2 chromosomes, and tri means 3. So we go from 2 to 3. We added on 1 chromosome. So in humans, this would mean having 47 chromosomes. And in tetrasomy, we always start with our 2. Tetra means 4. So how many did we add? We added on 2. So tetrasomy means plus 2 chromosomes. And in humans, this would mean 48 chromosomes. Okay. Let's go ahead and look at polyploidy now. So like we said, polyploidy is an abnormal number of sets of chromosomes, like having 3 or 4 at every location. And the conditions all end in ploid. And that ending of ploid should sound familiar because we know it from haploid and diploid, where diploid is your 2N, which is normal. Haploid would be 1N, which is half. And then we also have some other options. We have triploid and tetraploid, where tri means 3. So that means 3N, 3 chromosomes at every location. And tetra means 4, 4 chromosomes at every location. And the other prefix that you have to know can be either auto or allo, where auto means from the same species and allo means combining different species. So you'll have problems that say like, what would an allotriploid look like? What would an autotriploid look like? And you should recognize the auto or allo prefix saying, is it the same or different species? That tri, that means 3, and the ploid, which means polyploidy, which means that we're talking about every single location. And that's different from trisomy, which is just having 3 extra at 1 location. So we're going to talk specifically about triploids because there can be a little bit of issues with problem solving here for some students. So we're going to talk about how to do that, and then we're going to do an example. So allotriploid, let's break that word up. Allo means different species, tri means 3, ploid means polyploidy, so we're talking about multiple sets. So overall, what we just learned from that word is we have 3 complete sets of chromosomes, and it's coming from 2 different species. So How would we get 3n? Well, we would have to do 2 plus 1. That means you have a 2n plus a 1n. And remember, 2n means diploid and 1n means haploid. So we're combining a diploid with a haploid. And this can happen two different ways. Mom could have the diploid egg and dad could have the haploid sperm and they combine to be 3n. Or mom could have a haploid egg and dad could have a diploid sperm, they combine to be 3n. But it can happen either way, both are options. So the way that you'll solve these is you're going to write down the diploid and haploid numbers for both mom and dad. And then you're going to solve the two options. So how many chromosomes would be in the offspring if mom was diploid and dad was haploid? And how many chromosomes for the other way around? And both of these are going to be possible answers to the question. So now let's try a problem looking at everything that we just learned. So a tulip has 12 chromosomes and a rose has 20 chromosomes. A tulip and a rose mate. How many chromosomes would the offspring have if it was an allodiploid, allotriploid, allotetraploid, nolosomic, monosomic, trisomic, tetrasomic? So I'm going to split this page in half. And let's look at the endings of these words. So some of these end in ploid, and some of these end in somic. So remember that ploid, we're talking about polyploidy. And with somic, so somic, we're talking about aneuploidy. Okay, so I'm going to do all my polyploidy ones on the left and my aneuploidy ones on the right. But before we do that, I want to talk about what the parents would look like. So I want to talk about my tulip, and I want to talk about my rose. So I give you the 2n numbers for both of these, are the diploid numbers. So my diploid number for a tulip is 12, and for a rose it's 20. And then I want to look at the haploid numbers to see what would the haploid cells look like, what would the gametes look like. And for tulips, 1n would mean 6 chromosomes, just taking half. And in your rose, 1n would mean 10 chromosomes, just taking half again. So now let's start solving. So the first thing I ask for is an allodiploid. So di means 2, and ploid, we're talking about polyploidy. So this means that I want to have 2n in my offspring. I'm going to change that to just say 2n offspring because it's kind of running together. So I want a 2n offspring. So how do I get 2n? Well, I'd have to do 1n plus 1n. In order to get my 2n. So where do I get those 1n's from? Well, I go to my tulip and I go to my rose, and we know that they mate, so I have to get one number from each. My tulip, my 1n is 6, my rose, it's 10. So I would be doing 6 plus 10 equals 16. Now let's look at my allotriploid. So for my allotriploid, I want, since tri means 3, and ploid means polyploidy, I want a 3n offspring. So how do I get 3n? Well, I can do, 2n plus 1n to get 3n. Or I could do 1n plus 2n to get 3n. So we're going to go to my tulip and my rose, my little chart I drew out, and add those numbers in. So 2n for a tulip would be 12. And I combine that with 1n from a rose, which is 10, to give me 22. Or the other way around, I use my 1n from the tulip, 6, plus my 2n from the rose, which is 20. And that would give me 26. And both of these are options for my allotriploid. And then we're going to look at our allo tetraploid. So tetra means 4 and ploid means polyploid. So we're looking for a 4n offspring. How do I get 4n? Well, I would have to do 2n plus 2n to equal 4n. So if I were to look at my 2n numbers, I would have my tulip 2n is 12 and my rose it's 20. So I would do 12 plus 20 equals 32 for that offspring. And that's how I would solve those. So now let's look at my aneuploidy ones, my nolosomic, monosomic, trisomic, tetrasomic. And I am just going to write out the first letter for all of these. So N, M, tri, so a little more than the first letter, and tetra. Okay. So something important to keep in mind whenever we're talking about these aneuploidic individuals, unless it's otherwise stated, we're always going to be going off that diploid state. So like in humans, whenever we talked about monosomy, which is -1, we said, okay, that'd be like 45 chromosomes in a human. So we don't start at like a 47 chromosome state and then say monosomic would be 46, which is normal. We start at that diploid state. So I'm going to put that little note right here saying start at diploid. And luckily, we already did our diploid state. So in our allodiploid, we found that that was 16. So that means that we are starting off at 16, and that's the number that we're looking at. So in nolosomic, remember, we want 2 at every location. Null means 0. We went from 2 to 0, that's -2. So 16 minus 2 would give you 14. Monosomic is -1, which would be 15. Trisomic is +1, which would be 17. And tetrasomic is +2, which would be 18. And that's how you would solve all of those different types and what they're asking for. So really big takeaway, look at what the question's asking for. Is it asking for aneuploidy or polyploidy? And then apply your rules as needed. All right, and the next video is going to go through non-disjunction.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.